Morning class, we're going to be talking about section 3.1. I will have the tests finished grading this afternoon, so you can check that. I started grading it, so if there's small issues, I reference your notes first, so whatever work you showed is probably going to get you credit back just by doing it properly. The other thing is, what I've noticed is usually it's small mistakes that will get you. So what I want you to know is you should be very careful with inputting it in the delta map. That affects how you do it. But nevertheless, we'll be going into chapter 3.1. Today will be a shorter lesson. So for those who are hoping class finishes early, it will depend on how well we do during our call. So some definitions. Algebraic functions are what we covered so far. So this would be polynomial and rational functions. Okay. Transcendental functions. This is actually where we're going to be headed. This is exponential, logarithmic, and actually, and technically, trigonometric. Trigonometric, and others. There's others. Okay, functions. So we're going to look at exponential functions. Here's the definition. The exponential function f with base a is denoted by f of x equals a to the x, where a is greater than 0, so it can be a fraction, but it is positive. A cannot equal 1 because then it is not an exponential. One-to-one property means that the function for each x, for every single x, there's only one output, one unique output. Natural base is e, which is the number 71828. Let's see if I write it right. 71828. 18, and then it goes off. Okay, it's not repeating this idea, it's actually, this function is pretty easy. It's f of x equals e to the x. Now, this natural exponential function is going to be crucial. This idea is actually from a limit. So I'm just going to write it. You don't have to understand it yet. It's a limit as x approaches. Could go two ways. Let's just do infinity because it's easier. As x approaches infinity of 1 plus 1 over x to the x. Now this is actually usually n, so let's just do it appropriately because you're gonna see this again. So as n, so this is the limit as n approaches infinity. You don't need to understand this, but this is the idea behind the base e. Okay. It's continuous compounding. We'll talk about that later. Okay, example 1. We're going to look at this on the board. So example 1, we're going to plug this in. You can actually just plug this into the calculator. So if fx, okay, this is a garbage one. Apologies. Okay. Okay, f of x equals 2 to the x. G of x equals 2 to the negative x. And then h of x equals 0.6 to the x. So if we're plugging in negative 3.1, you could do this with the calculator. So you do f of negative 3.1, g of negative 3.1, and h of negative 3.1. And I'm not going to have a calculator, so I'm just going to show what it would look like. You do 2 to the negative 3.1, so if it's 2 to the negative 3.1, that would become 2 to the 3.1. So notice these two are inverses of what the number is going to be, and then you have 0.6 to the negative 3.1. So you just plug this into calculator, and it's going to give you solutions. You can use calculators for plugging it in. Okay, I have no opposition to calculators here because there's no sense in you memorizing how to do this by head or through with your head. So no need. Okay, graphing exponential. So let's zoom in on this briefly. Okay, you want to make a table with 5 or more points. For x, you're going to plug in -2, -1, 0, 1, 2, and 3. You could also change it, but it won't matter. Then you're going to make the table. So you make it for x, you solve for y, and plot points. Remember, draw a straight curve. Okay. And graphing this, let's look at Desmos. So Desmos, our f of x is going to equal, so f of x is going to equal 2 to the x. Then we're going to have g of x equal 2 to the negative x. So let's see what that happens. Notice what kind of thing happened. They're the same if you flipped it. So if this flips, if this is going to be a reflection over the y-axis, okay? That's a reflection of the y-axis. Okay, and then if we have 4 to the x, then notice it gets steeper based on this number. If this was some a, and we'll make a slider for a, let's start with 2. So notice, let's turn this off for a second. So we have 2, and then we keep going, it's going to get steeper and steeper. So a kind of acts as our transformation, as our vertical stretch for shrink, right? Okay, go, and then go this way, it's a reflection. So basically one uses, but yeah. Okay, and then if you have negative a is not, it's not even going to show up on our graph because it's just going to be points. It's going to look weird, so we'll not talk about that. Okay, that's how we graph it. Okay, let's go back to the, sorry. Okay, so these two, positive, will be sloping up and over like this, and these two will slope this way, like this. Okay, so here's some general rules. Our domain is going to be the interval from negative infinity to infinity. Okay, and this is true for both positive and negative, so I'm just going to write 1. Range is going to be from 0 to infinity. Okay, and that is also true for both. It's going to be never going to reach 0, okay, because that is going to be our y-intercept for just x is going to be 0, 1, and x-axis is a horizontal asymptote. That is that as a to the x approaches 0, as x approaches infinity. Okay. And this is going to actually be true for the other one, except the difference is going to be a to the negative x approaches 0 as x. Sorry, this is going to be as x approaches negative infinity. This is going to be as x approaches infinity. And you could just look at the graphs, it'll show. Okay. Okay, they're continuous, and that's all. And then there's this function over here is going to be increasing, and this over here is going to be decreasing. Okay. So that is going to be the difference between those two transformations. So this is going to be a y. This is going to impact our y. This is going to be so vertical shift. C is going to be horizontal shift. This is going to be reflection over the y-axis, and actually reflection over x-axis. This is going to be vertical stretch or shrink. And then technically, if you have something in front of CX, it's going to be horizontal. Okay, this is example 5. If you want to look at it, it goes through different ones. One-to-one property. Let's actually look at this because this one is important for how we will do the homework. Because I feel like it is a good lesson. So we're going to look at that. Okay. So one-to-one property we have. If you have something, 9 equals 3x plus y. Oh, thank you. We'll come back to this actually, okay, in the next video.